Good morning, students. How are you? As in the previous video, we are discussing about dimension and dimensional formula as well as dimensional equation. And we had discussed what about dimension, what is called dimension, what is the meaning of dimension of a physical quantity, how the dimension of a physical quantity can be expressed, what is dimensional formula, how the dimensional formula is formed, and what is the dimensional equation. After that, we had discussed about some physical quantities and their dimension formula. In continuation with the same video, today we will going to discuss some more physical quantities as well as their dimensional formula. So in the previous video we had discussed about impulse, dimensional formula for impulse. Now today, that is angle, and as you know that angle in radian can be defined as arc upon radius. It is defined as arc upon radius. As it is defined as arc upon radius, so both are lengths. This dimensional formula is L, this dimensional formula is L, and the dimensional formula is L to L cancel out, and it is equal to M0, L0 and T0. This is the dimensional formula for angle. Next is strain. A strain is what? Change in length upon original length. Since it is also the ratio of lengths, so it is also M0, L0 and T0. Next one is stress. Stress. Force into area, force upon area. Restoring force upon area. Restoring force upon area. Now, restoring force can be force have the dimensional formula mlt minus 2, mass into acceleration. So it will be mlt minus 2, and area is L square. So the dimensional formula is m L minus 1 T minus 2. L minus 1 and T minus 2. Similarly, modulus, so these two have the same dimensional formula. Angle and strain, these are both are dimensionless quantities having no dimension. Now stress, that is restoring force upon area, and modulus of elasticity. Now modulus of elasticity. Modulus of elasticity, that is modulus of elasticity is denoted by m, and this modulus of elasticity can be represented by stress upon strain. Stress upon strain. Since stress has its dimensional formula m L minus 1 T minus 2, and this is dimensionless having no dimension, M0, L0, 20. So it also have the dimensional formula ml minus 1 t minus 2, which is similar to the stress, which is similar to the stress. Now pressure, that is force upon area. Pressure, that is force upon area. Now tell me, force upon area. So force has dimensional formula ml t minus 2 and area has dimensional formula L square. So the pressure has its dimensional formula m L minus 1 t minus 2. So what we had observed? We had observed that stress, modulus of elasticity and pressure, all three have same dimensional formula. All three have same dimensional formula. Now frequency and angular velocity. Frequency and angular velocity. Frequency is denoted by nu and frequency is given as 1 upon time period. 1 upon time period means its dimensional formula will be m0 l0 t minus 1. Next one is angular velocity. Angular velocity. This angular velocity has the time angle upon time. Angle upon time. And as you know that angle is dimensionless, so it will be equal to m0 l0 t minus 1. Both frequency as well as angular velocity both have same dimensional formula, and it is radian per second and hertz. Its unit is hertz. Frequency has its unit hertz and angular radian per second. Radian per second, angular velocity. Both have same dimension. Now moment of inertia. This is rotational analogous of mass. Rotational analogous of mass is moment of inertia. This is moment of inertia, and moment of inertia can be represented by I is equal to summation mr square. I is equal to summation mr square, and it is the product of mass and distance, square of distance. So it can be written as ml square t0. Now angular momentum, kg meter square. Angular momentum. Angular momentum. Angular momentum. The formula for angular momentum is I into omega. I into omega. Now look at here. ml square for moment of inertia and t minus 1 for angular velocity. So the angular momentum has its dimension ml square t minus 1. All things are based on formula. If you are knowing the formula, something you are going to study in later on chapters, there also you are very much aware and cleared about the formulas, and very, if you are knowing the formula, if you are knowing the unit for that physical quantity, then it is very much easier for you to find out the dimensional formula. Now, surface tension. Next one is surface tension. Surface tension. Surface tension is defined as force per unit length. In elasticity chapter in fluid mechanics, you will study this. So m l t minus 2 upon length l, and it will give you m l0 t minus 2. m l0 t minus 2. Now spring constant. Spring constant. Spring constant you will study in mechanics. In case of friction, while studying friction, you will study spring constant, and the formula for spring constant K is equal to F upon X. The formula K is equal to F upon X. So you can write it as M L T minus 2 upon L, and it will give you the same ml0 t minus 2. So for a spring constant also, spring constant K is equal to F upon X L m L0 t minus 2. Surface tension, spring constant, and the similar quantity is surface energy. Surface, all the three: surface tension, spring constant, and surface energy. All the three have same dimensional formula. So look at for surface energy. Surface energy. Surface energy. Surface energy can be given as energy upon area. Energy upon area. Energy m L square t minus 2 upon area L square, and the same formula m L0 t minus 2. m L0 t minus 2. So the all the three, that is surface tension, surface energy, and spring constant, all have same dimensional formula. Now intensity. Last one is intensity. Intensity means how intense, matlab radiations per unit area. Rate of fall of radiation per unit area. That is called as intensity. Intensity. And it can be given as energy per unit area into time. Energy has its dimensional formula ml square t minus 2 upon area L square into time t. L square to L square cancel out, and it is equal to m L0 t minus 3. m L0 T minus 3. Its unit is joule meter square second or watt per meter square. This is the intensity. So a lot of physical quantities we had discussed here, and there are many more also. So you will try for that and look. There is a table in your NCRT book as well as in other books also. There is a 2 or 3 pages table which gives the dimensional formula, line equation, and units for all the physical quantities. So go through it and try to grasp it by seeing their formulas. So now we will discuss about one numerical regarding this, and after that we will discuss the right numerical. If a composite physical quantity, if a composite physical quantity in terms of moment of inertia, high force F, velocity V, work W, and length L. All things, all the physical quantities, whatever used in the formula for composite physical quantity in terms of moment of inertia, any composite physical quantity, there is a physical quantity which can be expressed in terms of moment of inertia I, force F, velocity V, work W, and length L. That is Q is equal to I F V square W L Q, where I is moment of inertia, V is F is force, V is velocity, W is the work, and L is the length. It is asking that find the dimension of Q. You have to find the dimension of Q. Dimension of Q. Dimension of Q is what? And identify it. Identify it. What is that physical quantity, and you have to identify. Clear? Look at the question, very easy question, very simple, only based on the technique or formula which we had studied. So look at here. First of all, I am writing the formula. That is, I is equal to, Q is equal to I F V square upon W L Q. Now look at here. I is what? I had told you moment of inertia, and it is equal to mass mr square, mass L square, and velocity F, then F. You are knowing m L square T minus 2. Then velocity V, it is equal to LT minus 1. Work done, ml square T minus 2. ml square T minus 2. Clear? Anything remaining? I, F, V, W. Length is length. No need to bother about it. Now, what we have to do? We have to put separately these things. So, dimension formula Q is equal to m L square L square T minus 2 L T minus 1 whole square and L square T minus 2 L cube. Clear? Now simple multiplication, what do you do? For variables, if x is multiplied by x square, then what will happen? If x is multiplied by x square, then the product is x to the power 4. So that simple multiplication we will do. M multiplied by m, and m is not here, so it is equal to m square. L square 2 to 4 and 1 5, L to the power 5. T is here 0, T minus 2, oh sorry, here L square, here also L square. So L square and L square, L to the power 6. Here T to the power 0, T to the power minus 2, T to the power minus 4. Clear? T to the power minus 2, T to the power minus 2, T to the power 0, T to the power minus 4. Similarly, here and L to the power 5, T to the power 9. Now division. You are knowing that x square divided by x cube is divided by x square. Then what will happen? It will go upside. X3 minus 2 you can write, and it is equal to x to the power 1. So similar things we do here also. Look at here. Dimensional formula for cube. It is equal to m L and this is equal to t to the power plus minus 2 and LT to the power minus 2. I is equal to ml square and this wrong thing happened. A force is mlt minus 2. So ml square and L square and L square, L to the power 5. Here L to the power 5, and it is equal to 0. Now it will become mt minus 2. It will give mt minus 2. Now look in the table. What is the dimension? So which physical quantity represents the dimension of mt minus 2? So I think force constant, surface tension, surface energy, energy per unit area. Clear? Surface tension, surface energy, etc. All these are the dimensional formula mt minus 2. mt minus 2 is the dimensional formula for these physical quantities. So that's all for today, students, and tomorrow we will discuss applications of dimensional analysis in mechanics. Thank you, students. Have a good day.